Well, hi, good morning. Thanks for joining me in my shop here. It's the last day of January, and we're going to start off with a really weird experiment. Well, the first part won't be weird. I just got a small radio, and you can hear the hiss coming from it. I just have it tuned to 11 megahertz, and I was curious about the hiss coming out of a little transistor radio versus the hiss coming out of this radio. Of course, there's no hiss coming out of this radio worth even talking about. This is so quiet. I think I'd have to look now, but I think it's 130 dB down the noise level. So I know simple transistor radios have problems with noise. So the question is this noise coming from the antenna, or is this the radio itself? The antenna is actually broken off this radio and have a piece of wire. So the wire is the antenna. On the end is a clip. Can you hear the difference? So I think this is atmospheric noise, but it just doesn't have the right characteristics. It's too consistent. But so perhaps the noise floor of this radio is what we're hearing, and then I'm applying a little more signal to it. I'm not sure. But that's not what's interesting. Here's what's interesting. Explain this. See the red wire? The antenna wire? See my hand? I'm not holding the clip. I drag the wire on the edge of the big old radio. So why the heck would you do that? Nothing much happening, eh? I'm now going to leave the room and return. Whoops, what happened to my radio? Hey, what happened? Don't give up on me in the middle of this. I think maybe the battery's giving out. Okay, so I'm going to, again, drag the wire. Okay, what would you expect to happen? Nothing. I'm now going to leave the room and come back. Okay, so all I've done is walk around. Okay, bring the radio back. You drag the wire now. I'm holding the clip this time. And see, there's another demonstration that makes me look like a complete and utter idiot. Okay, one more try. I think I know what I did wrong. Going for the walker. Okay, here I come again. There. What's happening? What's happening? Hey, it's gone. There you go. I know exactly what's happening. Yeah, you might too. I thought that was kind of interesting. I won't bother explaining it though. We'll let you figure it out. When I left the room, I didn't do anything unusual. Just walked around, sat on the couch for a moment, got up, came back in here. Didn't do anything unusual. Okay, now what are we going to do today? Today I have a couple of things here that, well, I think what I'm going to concentrate on are the outputs at the back of the radio, because I think the radio's ready to go back to its listening post. Once it's in its listening post, I have a hard time accessing any of it, except the front panel. So if I'm going to play around, now's the time to play around. I've done the tube thing, weak tube thing. What I find out, boy, you can have a pretty weak tube in this radio and not even know it. I've done the noise thing, just as expected. The noise floor is so far below the antenna noise that it's just gone completely. Everything else seems to be pretty good. I think what I'm going to do today is mess around with the outputs on the back of the radio. Try different things, looking at them in different ways, and see if I can come up with a useful way I should be utilizing those outputs on the back of the radio during my normal listening. Now, I've already managed to do this to a large degree. I brought two more terminals out on the back of this radio. One carrying the ABC voltage, well, a version of the ABC voltage, let's call it that. And the other one is the output right from the diode detector. And then the last one, there is a IF output that comes with this radio. So you have 3 different outputs, along with the audio too, I guess. What kind of instruments have I got? Well, I got an SDR radio, that's pretty interesting. I got the oscilloscope there. In my shop, I have an oscilloscope I could use back at my listening post if there's some interesting reason to use it. Signal generators and all the like. And of course indicating meters. I got just about everything in here you could possibly want to investigate what's coming out the back of the radio. Okay, maybe we'll do this, I don't know how to do this. Do this many things at a time. Yeah, let's do that. Many things at a time.
We are you really Elijah, and I'm going to tell you, Elijah prayed, and the Lord heard it, and then he prayed again, and God said, come on, you little Elijahs. Y'all want to be Elijahs? Just come right on up. You can begin in the prayer room.
Okay, got enough stuff to look at there? Wow. Well, let's start. Top left is my SDR looking at the IF output. It's already proven itself to be a fantastic tuning tool. I don't have to stare at this waving meter. I can look at where the signal actually is in the IF. So you can look, I can tune it a little off, tune it back in. I don't even have to listen to it to know it's perfectly tuned. Right there. A little curious about what that thing is off to the left of the response curve there. I tried to find out what that is. I don't know. I don't know if it's coming out of the radio or where it's coming from. Could just be an artifact of the SDR. So now, just below the SDR, you see the oscilloscope with some signals flashing on it. It's a little far away to see from here. Of course, we're listening to WWE. What that might enable me to do is to recognize overloads in the radio. That is looking at the diode output of the radio. So you're seeing the audio after having the well, I think the scope is on AC. Let's put it on DC. I think we'll start seeing the DC component. Just, it's too far. Let's go like that. So that line should wave up and down in conjunction with this meter. Pretty steady signal right now. So the radio is running on ABC right now, automatic volume control. And I have another meter here I forgot about. This guy here. I think it's still connected. So that's showing the ABC voltage. Okay, what are we going to do here? So I already know I have a great tuning aid in that IF display on the SDR. Let's look at the distortion problems. Now, we're in the automatic volume control. It's pretty hard to overdrive the radio here. In fact, I don't think it's going to happen with a signal on the antenna. I have to come up with something a lot stronger here. I'm going to flip this back to AC so it just sits. Flip the wrong thing to AC. Flip this. There. That'll stay in the middle now. It won't drift up and down with the AVC voltage. So one way to overdrive it is to switch off the AVC and operate manual. So I'm going to do that. I'm going to move you a little closer here because we're going to look right at the scope now. Where's that? Audio doesn't mean anything. The audio's dealt with after the signal's taken off here for the scope. So I'm going to switch to manual. It's on 0 right now. So I think at this point you won't see this meter do anything. Bring it up to it's number 5 on the knob. Should start hearing it. Let me turn up the audio way up. Audio's at 10. Okay, here it goes. So one thing I notice on the SDR is the general noise level is lower because the general strength of the radio is lower right now. I've got it set low. So the peak signal is far from the top of the SDR. I'm going to flip it to AVC. Let me just turn the volume down because it makes a huge difference. Now you see what's going on with the AVC. Now it's a little hard on the SDR. I should really pad down the signal to the SDR. Back to manual here. Okay, full blast on the audio. Question is this nicer to listen to? Or on AVC? Let's listen to this just for a minute. I'll be silent. Turned up just a wee bit here. So we're listening for signal to noise ratio and things like that. See the amount of audio in the radio is very, very low. It's not even showing much of a indication on this scope, but we're able to listen to it. So now I'm going to flip to AVC. So first the audio goes way down to like 2. And we'll turn it. So you can see now the signal on the scope is far, far greater. The audio is only at 4 now. Get a nice look at the sidebands. You can see them going down the waterfall from the tone that just came on. And as signals go, I mean, you can look on the S meter here. This is not a strong signal at all. It gets up around 60, 70, then it's getting pretty strong. I'm watching the noise go up and down on the SDR and watching the meter and listening. So the AVC should be knocking down the gain of the front of the radio, the first couple of tones. You should see the general noise level go down, basically as the signal comes up. There's those sidebands again. Nice look at them. Okay, let's go pick up
I'd like to see him face to face. Well, he'll kill you. Well, we'll find out then, won't we?
right in the middle.
Hit me, sir. Go ahead, hit me. Well, what's the matter with you, man?
Yeah, we'll play around with the bandwidth here. The bandwidth is set to 3 kilocycles. That's usually where I have it on this radio.
That's not my anointing.
A really strong signal, I'll open it up like this.
Kill me some harm and see what's going to happen. We're going to find out whether we're a prophet now, aren't we? Aren't we?
That sounds a lot better, right?
Yeah, we're going to find out. Yeah, we're going to find out.
You can see the IF bandwidth broaden.
We're coming down to the Waterloo now, brothers. Yeah,
Check
yes,
tuning.
sir. And then shall they know I'm God, he said. Here you go, you're going to find out. Think these men are going to go out
Thanks,
here
Senator.
and touch the anointed of God like they have?
Okay, we go even bigger.
You touch the people of God that God put under my care. You're doing me
Now what you're hearing is a fair bit of
You
noise.
intrude and you mess in their lives when they've been committed to my care. You're doing me harm.
So now we're listening to the noise. Let me just, so this red marker means nothing here. Let me just stick it
How many
over
men
here.
that turned away from the faith that God allowed me to put in their heart? You think you haven't harmed? Come on.
If I tune around now,
What's wrong with you?
okay, so there's WWV, way off on the left. So if it's tuned way off on the left, now I'm going to just turn the sensitivity down. Okay, the signal comes up again. And now it's just outside. Can't hear it. Bring it back in. Stop it down. Can't hear it. Tune it in. Now we'll go down to the crystal settings. It's a very, very sharp filter. And you can actually see on the SDR it looks pretty sharp. Let's tune a little bit. So you see from the meter on the right, there's a very small sweet spot here. Turn it up. Now there's a phasing control, which I'm going to move around now. That's the 0 setting. That's where it really should have been there. Now look at the waterfall display. It's interesting. And I'm going to rotate it 180. Actually, you know what? What exactly is going on there? Tuning. Negate that other. Just look at the shape of this while I rotate this knob. Seems to favor one side or the other. What's the difference between 1 and 1 on either side of it? Whoops. 1. Okay, so what do these numbers mean? 3 kilocycles plus. Kilocycles and minus. I never noticed that it said plus and minus there. It's kind of hidden by the knob a little bit. Oh, I probably noticed years ago. So, is this correct now? Maybe there's an alignment issue here. Or can you? Is this indicating I didn't quite get the IF bang on? But let's go down. Let's tighten it even more. We'll really get the effect here. Okay, first I'll try to tune in something. expand the SDR so we can see more clearly what's going on.
59 minutes, coordinated universal time.
Oops, that was it. So the red line is right on 4:55 now. It doesn't mean anything else. I'm just marking it for us. Okay, start the control here. So remember, I tuned the IF to match this crystal. Can't see, I really saw much of anything going on. Okay, this will be like that. Forever trying to switch.
Hour. Coordinated universal time. National Institute of Standards and Technology time. This is radio station International Allocated Standard Television Agency. 15.
Okay, so look at the display now. On the left side, you see a little more than the right side. I'm just going to whip it the other way. Now it's a little more on the right side than the left side. You can see it on the waterfall display too. It's kind of a notchy thing showing up right at 4:56 on the right side. Which is, you know what we need to do? We need to tune in a signal generator and do this kind of stuff here. That would be a good idea. So I'm going to go to a fairly quiet spot here. Something about 10. Set my signal generator here to, it's almost there, 10. Just above 10. I've got it hooked up to something. Okay, flip to the signal generator. Okay, let me check the calibration here quickly. Calibration's way off. Okay, we're calibrated for a 1 microvolt signal on here. There it is. So that's 1,000. This is the thing, 1,000 hertz modulation, but I'm on the 500 kilosecond, 500 hertz filter. So in a sense, you really shouldn't be able to hear the 1,000 when I get this right on the money. I think that's right on the money there. Whoops. You still hear it. Now if I flip to 400, should it get louder? Well, I don't think it got louder. We can see the two sidebands there quite clearly. If I go out to the 1,000, you can see one on the left, the one on the right kind of suppressed. Okay, so let's turn this control some more here and see what happens. So now you can see in this setting, the sideband on the right is strong. Just a second here. That's 400. There's something else in there, you can see it. Okay, and the crystals are right on 0. So we'll go this way. See, it's looking for it on the other side now. Looking for it, that's not quite the right term. So I'm able to null out the one on the right, or null out the one on the left. You don't need both sidebands, you just need the carrier and one sideband. Your radio can reproduce the signal. So this isn't doing quite what I thought. I always imagined this was moving a notch filter across. Yeah, and maybe maybe in a way it is. Maybe. We need to find a station interfered with heterodyne to really see this guy work really well. Let me open it up. This is the most open crystal setting. Now, if there was a heterodyne signal on the right, where the signal generator sideband is, goodbye. Just get rid of it like that. I've always found this control to be pretty effective. You can probably still imagine it's a notch filter. Now, what about this plus and minus thing? So we're on 0. If we go plus, upper one disappears. If we go minus, the same thing. Look at the control. I mean, how different can each side be if they're at the same point here? I mean, they have to be converging on this point. So plus and minus, I don't know what that really means. Okay, now let's go back to the regular setting here. You can see both sidebands. This is on just the ordinary non-crystal setting. This control does nothing now. Okay, let's fool around with the BFO. Bring the BFO on. Raise its pitch. Right on top. So that knob is getting turned around quite a few times here. It's not supposed to, right? So this knob, sorry if I'm blasting your ears off here. This knob, this out of focus knob, you can still see what I'm doing, is supposed to only turn that far and that far. But I can turn mine all I like. I know enough now about how this is built inside. I got a good enough picture of it in my head that I can avoid the turning it too far. I can feel the tension build on it. Like I mentioned before, a lot of SP600s have a defect where that knob has been turned too far and it's ripped the coil. What we're gonna do now? Okay, let's try some overloading stuff. I have the signal generator running. There's some. Oh, I know what the hum is. I left the BFO running. Okay, so you got a good look at the scope. Kind of a look at what I'm doing. So what I want to do is I want to overload this radio. So let's get rid of the BFO. Tune it in nicely. Yeah, really, look up at the SDR is the way to do this. There's no arguing. We've got it tuned in right. Now I'm going to raise the input level to the antenna until something happens. I don't think the SDR is going to help us. I think it's all about the scope here. Okay, up by a factor of 10. I'll turn the volume down here so we're not blowing your ears off. That looks perfectly fine to me. What's this thing triggering on? It doesn't really matter that it triggers. It is not triggering. Well, I'm not going to worry about it. We'll just let it carry on there like that. Okay, so I'm going to go up another 10. So this would be, let's see, 6 times 10, 6 microvolts on the antenna right now. 60 microvolts. 600 microvolts. 6,000 microvolts. I got nothing left. That's 60,000 microvolts. I'm not sure what that would be in normal language. Well, the scope didn't indicate any overload problem at all, and this is a signal far beyond what would come in on my antennas. Now I guess if you're hooked up to some huge monster professional shortwave listening spy antenna, maybe the signal strength can be much higher yet. Maybe big whopping antenna, but wow, no indications of any problem. Sounds fine. I would notice this though. The signal strength meter is gone. It's not quite at the top. Hey, let's calibrate this guy again. Another attempt at calibrating that while we're doing this. It's supposed to be 1 microvolt at this upper zero here. So we're going down. 10, 100, 1,000, 10,000. It's 1/10,000th of its previous strength. The actual amount now would be 1 time, it'd be 6. It's way above zero. So I'm going to reduce this to what would be 0.6. That made quite a difference. So 0.6, so I'll now try to raise it to 1, and it should fall on that 0, but I don't think it's gonna. Okay. Oh, hang on. I gotta do it this way. Ooh, hold on. Big trouble here. Like this. Like this. Okay, starting the game. So this is now 1 times 5. This is 5 microvolts. Then we're only at -6. We should be at 0. We should be well above 0. Is it really 5? 10, 6, 5, 1, yeah. Is it calibrated? Well, yes. That meter's way off. I don't think there's anything I can do about it. Now, there's a meter driving tube. All tubes are not weak, though. So I guess I can recalibrate this in my head, in fact, and say, okay, you know what? Let's put this on 1 and see where 1 really shows up. And I'm not going to do that. I'm going to do it on, I think, 1. 1 would look like this. That's 1. That's basically right on the bottom here. And what happened up on the my signal generator is drifting. Let me just fool around here a bit. Yeah, my signal generator has a drift when you change the output. With this control anyway. Now there's another way to change the output. This one. It doesn't cause a drift. There you go. Another lesson learned about my own instruments. So on this signal generator, there's a calibration control, it's a set carrier, and then there's an adjustment here, a vernier you can fool around with. If you adjust this one, you see the frequency drifts. I never knew that. So you get this one set though, you calibrate against the meter. Once it's set, you leave it for the frequency you're on. Then if you want to make smooth adjustments, you use this control. And you see, look at that, the frequency doesn't change. So lessons learned all the time. Lessons. This control here will result in a calibrated output coming from here, but it switches off my frequency counter. Let's see what happens when I switch this to bring on the frequency counter. We should see a drop in signal strength. Wow. On this radio? Yeah, I guess you can see it right on the meter here. So this would be higher and lower. So that's calibrated. Once again, one last check. We're at about 3.5 microvolts on the antenna. Now, it's questionable, and it's reasonable to question this. The signal generator may well be calibrated to produce exactly 3 microvolts here, but what's getting right to the radio is debatable. Can't be more? Can it be more? I don't think it can be more unless you have some really weird resonance thing going on. So it's bound to be less. It's quite a bit less. Now to get this onto 0, let's take that approach. Let's say I want to make that meter say 0. I think I already did this, didn't I? I'm going to do it again. Now you've got a terrible parallax problem in the camera angle, but so that's about a 0 there. And we're doing this on one band right now too, which I really. So there, to make this meter 0, you have to go 1, 7. Well, that's not so bad. 7. Instead of 1 microvolt, it's 7. That's a little high too. Let's just back this down. Seven. So if somebody said, "Oh, this should be 1," but it's actually 7, that doesn't sound that bad, really, does it? Don't think so. Well, now, if I was able to calculate like a smart guy, I could take this 1 microvolt, do another measurement way up scale here, and see how it compares by using the decibel calculation. I could turn it into volts. Let's do that. So I'm going to push this up to, let's say, 60. And then I'll have to go away for an hour and calculate this. Okay, up to 60. That's pretty much 60 right there. That looks about 60. So to get 60 decibels above 0, above 1 microvolt, you need 100 times, oh, this is really low. Let's do this. We can go down here and go way up on this guy, way up on this guy. See if we can get back to the same 60 here. Okay, that's 60 on the meter. Well, now it's off scale up here. So it's basically 10 times 10, it's 100. Or 100 times 1 to get there. It's just it's so hard to read down around 100. Okay, that's 60 there. 100. Oh, it's up around 2 now. Ah, who knows what's going on? Oh, this has to be over here. No, that's right. That's correct. That's correct. All correct. And the result is, the final result, 2 times 1, 200. 200 microvolts. Write that down. 200 microvolts gives you 60 decibels. Does it really? So I'm going to go away and calculate this. Okay, so that comes out to 1,000 microvolts. So we should get 60 here with 1,000 microvolts. What do we actually got going here? 100 times 2. 200. Yeah, so so this meter is just out in every direction. Let's just see what happens if you get it up to 100. How many microvolts on the antenna? Only this one band here too, Jim. Wow, look at that! I can't even get up to 100. So you know what I just did? I went up by a factor of 100. It's 100 times what it was. It was 200. 20,000 microvolts. 20,000 microvolts. I can go higher. Let's put it right on 100. You can see in the, you can't see it because of this lighting problem here. Watch the ABC meter over yonder. As I'm getting up towards 100, that meter is, it's only 15 volts. Not as much as I thought. So we're 100. And the actual output is 10,000 times 8. So it's 80,000. 80,000 microvolts. to get it up to 100. Now I gotta check my little calculator over here. I think it's gonna pop up on the screen when I do this. Did I leave it on there? Yes, I did. So I do 100 here. What do we get? Should be 100,000 microvolts. 100,000 microvolts. And what did I say it was? I said it was 80,000. Hey, that's not bad. 80,100, you know, for the accuracy of these kinds of things. Okay. Great. Now, just gotta make sure that number is pounded in my head. So 80,000 microvolts is the same as 80, let's say 100 millivolts. So 0.1 volts. So at 0.1 volts on the antenna, this thing's coming up to 100. Something like that. In normal operation on my antennas, this has not gotten to 100, but maybe now after being aligned, it might. Maybe not down here in the shop because of the length of the lead-in. Why so quiet? Oh, because I have a kind of hearing right inside my signal generator, the faint hum of the signal generator. It has no modulation, so we'll give it a little modulation. There, doesn't that sound better? Doesn't that make you feel better? I'm going to turn this down now. So the other thing about this radio is it can handle a whopper of a variation of signals, and you've seen it here. It's gone all the way from almost 100,000 down to a couple of microvolts, and the output signal remains pretty stable. It's really, really good. Really very good. So we're trying to get some audio distortion happening here. We didn't succeed. I think I could force it by taking manual control of the RF gain, and we'll watch some of the stuff that happens here. Turn this down. Okay. Here we go. Well, we gotta turn the volume way up so we can hear it. It's amazing, eh? Not a sound. Hard to believe. Not much appearing on the scope yet. The scope is set 2 volts per division. Okay, we're going to turn this down. It's going to get loud. So you can see a DC effect on the scope. And we see multiple sidebands on the SDR. Shouldn't there just be one sideband at 1,000 hertz? We take the center one here, and we look at it. That's exactly 455. Wait a minute. What's my pointer doing here? Got this thing stretched out so wide, I guess. Okay, so 455 is where the red line is. Doesn't want to work for me. How come? It won't read it inside here, so I'm just gonna move this there, and then I'm gonna have to do this. Son of a gun, there's the thing again. Ah! There. Okay, now I can scan around here and I can read the frequency exactly. So 455. Whoops. Oh, I didn't want to do that. Talk about it. Get it back over here. Just a fluky way this thing works. So there we are, 455, and then the first sideband. Wait a minute, 455.7. We're 456.7. So that's what we're hearing. That's the 1,000 hertz being generated. What's this one doing out here? Is this going to be 2? 2. That's maybe a a sign of overloading something. Let's see what we can do to get rid of this. Is there some kind of adjustment? Get rid of that. Now audibly we can't hear it because it's double 1,000 and it's lower, so it's just kind of disappeared into the 1,000 sound. You know. Okay, so if I want to get rid of that, what would I do? We are on manual. Let's go to automatic and see if it disappears. No, it's still sitting there. Now let me look over and watch what happens. Didn't make any difference really. Ooh, 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 ooh. Did anybody see that? Ho ho. Okay, now my scope. I wish it would sit still. Let me just knock it down another size. Okay, watch what happens. I'm going to turn this really slowly to try to keep the scope on screen. So you can hear when you hit the point where the more harmonics appear, right in here. Can you see on the scope? It's a little hard to see. Maybe let me speed it up here a bit. I wish it would stand still. Maybe I can get it to stand still. Come on, stand still. Why will you not? Trigger mode auto. I have no idea why this. I have trouble triggering the scope all the time. Yeah, it doesn't want to trigger. Well, too bad. Yeah. That's. Oh, you know what I can do? I can cheat. I can cheat it. I can cheat it with this. There. Good show. Now, let's continue pushing the RF gain up and watch it. So, right at the point where the distortion happens, if you look at the bottom of the sine wave, you can tell it's no longer as sharp. Even now you look at it, it doesn't look quite as sharp as the top. There, you can really see it widening out there. Oh, that's really distinct. You can see it's just cutting it right off. I'm just turning it up louder and louder. So there's a cutoff point and the nonlinearity starts introducing harmonics. And if we can stay below here. Now what about that other thing? Is that other thing a harmonic too? I'm just going down, down, down. So now we've gotten rid of the other two where they just sink into the noise. I'll turn up the audio. Now I'm going to turn up the RF gain, bring up the other two, which have disappeared, and see what it sounds like. I'm going to turn down the volume a little bit here because I think it's going to get loud again. Here we go. There they are, coming up out of the noise. Sorry about the volume, but it's quite distinct when the others come in. But that first one, I can't really hear it. The sound sounds hard to me. That's the way I would describe it. Maybe that's because of that extra harmonic coming in there. It gets hard right in here. But I don't know. But definitely let me turn it down a little further. So if I'm listening using manual RF, and the input signal's going up and down, I'm going to imitate that in a moment. So we're going to set this so all we get are the first two harmonics. Okay, listening to the signal going up and down in signal strength. I'm going to make it go up and down. You know what, I got to make it down. And then I got to turn up the radio here. That's the audio coming up. And just a touch more signal. Okay, I am now going to punish the radio here. So that noise, that distortion right in there. Wait a second, I have to turn off. I'm going to have to turn off this, which is maybe easier on our ears. We don't have the sidebands now, but I know where the control is. The control was set about here. That's 5 times 100. 500 microvolts is causing that. That's the limit, so to speak. 500 microvolts. Now what happens at 400? We still have the extra sidebands there. You have the 2 close in. You have the 2 close in, and then 2 more. Let me just check the. So the carrier level is 35%. What if I take it down a bit? Is that what's being overdriven? Let me do something else here too. Let me just change this a little bit here. Get the impression I'm just playing around? Yeah, I'm just playing around here. I wanted to kind of get the top on the screen, but it's just stretching itself. And what were you thinking? I forgot what I was thinking. Another interesting thing I've noticed with the SDR is that there's lots of times, you see the signal there? Yeah. Okay, that's the radio turned up full blast audio-wise. You can't hear a thing, but you can see it. So sometimes when I'm doing shortwave listening, I'm not even listening. Well, I'm listening, but I'm not paying attention because I can't hear anything. I'm clicking on these tiny little lines on my SDR and checking it, and sure enough, if they're bang on a decade, you know, like 10, like a million 10, not a million 11.2. If they're right on a million 10, it's almost certainly a international broadcast if it's in the broadcast band. And so without actually hearing any program material or anything coming out of my speaker except noise, I'm able to click through these different signals and look, you know, in the on the internet, the frequency, and check what stations it is and all that kind of stuff. I can actually track and follow signals that can't be heard at all because they can be seen on the SDR. Now, the SDR here is looking at the IF. I'm talking about using the SDR as just a radio, just a straightforward radio. And I get a lot of fun out of that. And then you can get on those really weak signals that you can see on the SDR but not hear. You can sit on them and you can wait. Maybe play with your antenna or do something to try to bring them up. And inevitably it's some, well, it's a weak signal. You know. What am I doing here? Why did I do that? Tuning the radio. Just get it without even listening. Now there's another thing off to the right there that's moving in opposition to the main thing. So see, I'll move the main thing to the right, to the left, and that other thing heads off to the right. I'm not sure what those things are. I'm still unconvinced about them. I think they might be just an artifact of the SDR itself, but it could be an artifact of the fact that the radios shift frequencies and have a mixer, and they mix whatever comes in, and who knows what's going into those mixers sometimes, and give you a whole pile of stuff that's happening in the radio, but outside of the range that the radio can hear. But you can use your SDR and see this stuff and realize, wow, there's all kinds of weird things going on inside these radios. The signals, double, triple signals, running up, running down, running twice as fast, running half as fast, as you tune around using an SDR. So, and doing these kinds of experiments. Where'd it go? I lost it. Oh. There we are. No. Yeah, there's no question having an SDR connected to the IF output of this radio is really helpful. No doubt about it. Using the scope, not so much. So it's been a couple days since the last bit of video you were just watching there, and that was the last thing I did with that radio. It's gone back to my listening post, and I'm slowly working it back into my where I actually listen to it. I'm still working on it a little bit, but not here in the shop, because here in the shop, remember, a couple days have gone by now. I have the next guy in here. I have this guy in here. I'm working on it. So thanks a lot for watching the series on the SP600. Look, there's lots of people who know a lot more about that radio and would take it a lot further than I did. What I'm really trying to do with these two big old radios is make them secure for operation for the next 10 years or so, something like that, so I don't get some kind of failure in the radio that ruins it or something of that sort. So again, thanks a lot for watching the videos on the SP600. There will be one or two more. Hoping to get this guy and the SP600 set up in a video arrangement, which I have been unable to pull off for the last few years, so I can make videos right at my listening post and we can all listen to my radios together. So again, thanks a lot for watching that, and you know what, this is the next video here.